So chapter 7, here we go with a nice, hopefully easy start for your life. This is basically a 7th grade math lesson, retread. Some of the problems are a little bigger than what you were asked to do as a 7th grader back in the day. But what I'm going to try to do first is tease out of you a word and a definition by putting numbers in lists. So if you figure out the word or the definition, don't start yelling, this is called blah, blah, blah. Let's wait till we get everybody a chance to kind of think along. So there's going to be 2 categories today, and I'm going to just put numbers in these categories. So 2 is in this club, 3 is in this club, but 4 is not. 4 is part of this rule. 5 is one of these, while 6 is one of those. And it's not evens and odds. How do we already know it's not evens and odds? Because the 2. 2 went here, and then, that isn't how that goes. 7's one of these. 8 and 9 and 10 are all one of these. Again, supporting the fact it's not evens odds. Although most of what's over here is odd, there are odds over here. And although most of what's over here so far is evens, there are evens over there. So it isn't quite that. In the teens, 11 and 13 and 17 and 19 go in that club for some reason. But the rest of the teens, 12, 14, 15, 16, 18, even 20, those numbers are all in this other club, which is a little bigger. It's more than 50-50 that we're going to find these. There's a reason why they're going in these groups. You've seen these groups before, you've heard these names before, you've had these definitions before. This is 7th grade-ish, other years too, probably as well. Don't tell me names or definitions, but if anybody thinks you know what's going on, give me something that's in the 20s that's in this family, just one number.
23?
23 is one of these numbers. That is true. Can anybody think of another number, if you think you have this figured out, another number in the 20s that's one of these?
25.
25 is not. It's going to go over there. Well, we already got you. Anybody else can spot a number in the 20s, part of this club?
29?
29 is in this club, yes. That's the only ones in the 20s in this club, are 23 and 29. Other than those 2 people, can anybody tell me what's special? Don't give me a title, but like an explanation. What's special about 23 and 29 that puts them over here? And all of the other numbers in the 20s are in this other club. Anybody other than the 2 people that gave us 23 and 29? Can you think of something that's special about them?
Nothing can divide into them.
Nothing can divide into them. So we're going to put 22 over here. Just anybody in the room yell, because who goes in? 2 goes in. Or 11. Lots of stuff goes in. 24 because of 4, 6, 8, 3, lots of stuff. 25 because of 5, 26, 2, 13, 27 because 9, 3, lots of stuff. 28 because 2, 4, 14, lots of stuff. The 29 had to go over there. I think you said nothing goes in. It's the way you said it. It's not quite exactly what we want to say.
Only one in itself.
Only one in itself can go in. So these numbers, what they have is 2 somethings. What are those called? The numbers that go into other numbers? Factors is correct. So this category of numbers, they have 2 factors, 1 in itself. The only numbers that go in are 1 in itself. So if we want to think of somebody in the 30s, who in the 30s only has 2 factors, 1 in itself?
37?
37 would go in there. 33, no. Who messes up 33?
3 and 11.
3 messes up 33. There's one more in the 30s, other than 37. 31 is, why not 39? We're getting a little bit tough, but does anybody remember a quick way to know somebody that messes up 39?
Because if you add 3 and the 9, you get 12, and that's divisible by 3.
correct. We had a bunch of divisible by rules, and 7th grade's doing those right now. They're not enjoying it all that much. But how do we know the 2 goes into numbers?
If it ends in an even.
Because if they're an even. So the only even that can go in this list is 2 itself. Every other even number, 2 messes it up for all the other evens, because evens can be divided by 2. The rule for 3s is if we add up the digits, and 3 goes into that. So we just encountered for every 9 is going to be over here, because 3 plus 9 is 12. 3 goes into 12, so 3 goes into that number. Rule for quick check on 5, what messes, what?
If there's a 0 or 5.
0 or 5 at the end, 5 would mess those up. We don't have to worry about 6, but if you remember, anybody remember the rule for 6?
If it's divisible by 6.
Divisible by 2 and 3. But if you have a check for 2 and you have a check for 3, today, we don't really need a check for 6. Just check your 2s and your 3s. Some of the other ones, we have a check for 9. 9's basically the same check as 3, add up the digits. But since we have a check for 3, you don't really need the check for 9. But if we have 2 factors, that is going to go in this club. Now let's give away the name. Does anybody remember the name of that club? It is prime. So today we're going to talk about prime numbers having exactly 2 factors. There's another category that it has 3 or more factors. So as soon as you, always 1 will go into anybody. Always the number itself goes into anybody. As soon as you think of a number other than those that goes in, it's in this club, which is, it is called composite. Chalk skipped on me. I can go now. So composite is all the numbers that have 3 or more factors. I'll look at the homework with you in a minute. I'm not sure if they have you in any of the problems just judging, is it prime or is it composite? I'm not sure. Do they? No. Okay. What I'm positive they'll ask you to do is find a thing called prime factorizations. So prime factorizations, your job is write these numbers as a product, and product we all know well, hopefully, means multiply. So we're going to multiply, but only with primes. So they're going to give you a little number, or maybe they give you a small to medium-sized number, maybe they give you a giant number, but they're going to want you to somehow break this all down so you have multiplying primes to make this happen. 10 is like super easy. For multiplication to make 10, there's only really one simple way to make 10 for multiplication using primes, which is 2 times 5. You can't say 10 times 1 because we just decided that 10 was composite. So we're not going to use 10 times 1 because 10 is a composite number. But 2 times 5. 2 is in our prime list, 5 is in our prime list, 2 times 5 is 10. Question about that, like baby one. 12 is slightly tricky. So when you were in 7th grade, this blew your minds for about 2 minutes, and then somebody would come up with the idea. I'd have people yell stuff like 2 times 6, and I'd say no, because 6 is composite. And then they'd yell 3 times 4, and I'd yell no, because 4 is composite. And somebody would say 12 times 1, and I'd say no, because 12 is composite. And then they'd sit there and like stare at me and think, this can't be done by a human being. And then some smart 7th grader would say, I have the solution. And you have that breakthrough moment.
Can't be done.
3 times 3 times 3, like not more than 1 3.
More than one number. We're going to have to use more than one number, but what you said isn't quite it. But yes, the breakthrough moment is you can't always do it with 2 numbers. Sometimes you're going to have to multiply 3, 4, 10, who knows how many numbers you might have to multiply. So using only these, and use repeats and stuff if you need to, we need to make 12 happen.
2 times 2 times
2
3.
times 2 times 3. And then we have maybe an elementary school flashback, because most people did this in elementary school. Does anybody remember like a thing, a math tool, a style of writing kind of looking thing that helps you do these?
Factor trees.
Factor trees is correct. So when you start to need more than one number, sometimes people start to need to do factor trees. So what you're thinking is, think of any way you can multiply to get 12, but not using 1, because 1 doesn't help you at all. But what's a way to make 12 happen?
6 and 2.
6 times 2. And then think, is 2 a prime? Yes, so we're happy with that. Is 6 a prime?
No.
No. So we have to resplit 6. What's a way to get 6?
3 and 2.
3 times 2. Or 3 and 2 both primes.
Yes.
So then we're done. A different student might not have said 6 times 2. Somebody else might have said, I get 12 from doing
4 times 3.
4 times 3. But we're happy with 3, and 4 is
2 times
2 times 2. And if you look at the bottom of branches of the trees, don't use anything that you cut into 2 numbers, but all the ones that were done getting cut, all trees will create the same answer of a 2, a 2, and a 3. So I'm going to clear a little board space on that because I don't have space to write the answer. But you can put 2 times 2 times 3. And then usually some kind of wise guy 7th grader who knows more math than his peers will say, can I write these with exponents? Because I don't want to write all those 2's. Instead of writing 2 times 2 times 2 times 2 times 2, can I just do 2 to a power? And the answer is sure. If you want to write 2 to a power times 3, we're good. My only ask of you is when you write these, do them from littlest to biggest, because some of these are going to have like 6 answers. So if we come around the room tomorrow, my book is going to have all the answers from the littlest 2's to the biggest, whatever other numbers they end up with. And if you come at me with like, I have 5 times 3 times 7 times 2 times 2 times 3 times 7, I'm going to be like, you know, man, slow down. So I'm not like trying to skip around with you, and all your classmates are too. If we all just build from 2's to 3's to 4's to 5's up the list, it's easier for us to check. But if you don't have to use more than 2 numbers, just write the answer. But if you need a couple numbers, I would suggest making the trees. Could some people in here do 24 in their head? Probably. But you're going to have more success making a tree out of 24, so I'll ask for some trees. 24, what's a way to get 24?
12 and 2.
12 and 2. 12?
6 and 2.
6 and 2. 6,
3 and 2.
3 and 2. Can any of those split? No. So it would be 2 to the third and
I mean, 3.
a 3. Helpful tip, if you want to keep your trees shorter and use a little less paper, pick numbers that are closer to each other. So if you go little number, the little number will always partner with a bigger number. If you want to keep your trees a little shorter, try to step toward medium sizedness as fast as you can. What would have been a more medium size?
6 and 4.
6 and 4. And then 4 is
2 and
2, 2. 6 is
3, 2.
3, 2. Same answer. We're both right. One person used a little less paper. If that's a goal of yours, then try to get as medium size as you can, but whatever gets you the right answer, I'm good with. Question about 24. 48, a little bigger.
24 and 2.
You could go 24 and 2. And then if you want to use your previous problem, we can be done already. How?
Because the 6, the 4.
It's what we just did.
2, 3.
So it's going to be the same answer, but with
Another 2.
another 2.
So 2 to
So
the 4.
2 to the 4 times 3. That's legal. If you do a whole page of these and you find them, bump into one you already did, just recycle it. If we wanted to keep our tree as short as possible, would you
12
use?
to the
12-4 would be shorter. Even more equaled out.
6 and 8.
6 and 8 is about as even Steven as you could get, and neither of those is going to take you much longer. 2, 3, 4, 2, and then you get one more sneaky level of 2's. But 1, 2, 3, 4 2's, and a 3, no matter how you do it. Something there. 100. You go 52. Personally, I'd rather go.
25, 4, or 10 and 10.
I'd rather most go 10, 10. If we just keep them balanced, I'm not going to need much board space, but everything you said is right. I'm not in any way criticizing your choices. I just, personal choice, I like to go short trees. The 10s?
2 and 5.
2, 5, both ways. So 2 squared, 5 squared. Camera can't see it, I don't think. We don't need to turn it. They can just listen. It's their fault for not being here if anybody's ever watching this. But what's hidden is off screen, there's like a 17.
They can see it.
Okay, they can see it now. So a thought on what to do about 17. I need an answer on the, you know, it's a quiz. I need an answer to go in the blank.
1 and 17?
It isn't 1 times 17.
It's a prime?
It is itself a prime. So what is the answer?
There is one.
There is an answer.
The prime number.
I just want a number answer.
0 with the thing.
17?
Just put 17. If I give you a prime, just put it in the blank. Because our goal is to write primes, so we would just write that prime. Just write it. That's all you have to do. I would mark 17 times 1 wrong based on a conversation we're about to have, not one we did have. If we go back to the definitions, and you can turn back up because the action's all over there. What's up with 1?
It's not on either.
It's not in either list. Is it not on either list yet because I didn't get around to it yet? Or is it not on either list because it doesn't belong on either list?
It doesn't belong.
It doesn't belong. Because how many factors does 1 have?
1.
1. So to be composite, you need 3 or more. To be prime, you need 2. 1 only has 1 factor. So 1 is not prime, 1 is not composite, 1 is in a category like all of its own, and sometimes that happens and it's okay, but 1 is not a prime. What other number at one time just went in a category all in its own in discussions you've had?
0.
0. 0 is not
A positive.
positive
or
number. 0 is not a negative number. 0 just is what it is. It just stands in its own category. Today, 1 is like that. 1 is not in either of these categories. If it were 7th grade, that's how far we'd go and we'd have called it a day. Okay, this book, we're a little bit older and wiser and the class is advanced. They're going to give you some bigger numbers than what you've seen before. So like the 7th grade book wouldn't have given you 198. It may be hard for you to find the 2 medium-sized numbers like I was trying to do that go into 198. So just find any number that goes into 198 and we'll start with that. Any number that can go into 198. 2. How do we know when 2 goes into anything? If it's even. That ends in an even, so 2 goes in. What's another number we could have spotted without too much trouble?
3.
3. How do you know 3 will go in?
Because you add them all up.
If we add those digits up, that adds up to 18, so 3 would have gone into that.
6.
Since 2 and 3 both work, 6 would work. But we just have to find something to get us started. But then the question becomes, how many times does 2 go into 198? And you may need to like do some stuff like this today to just get that worked out.
4.
2 into 198. Scratch it. It is 99. Then we look to attack 99.
3 times 3.
We could go 3. 3 goes into 99. 33 times. Then who goes into 33?
11.
11. How many times?
3.
3. Are any of those not prime?
That's it.
That's it. So we're good. So I prefer on littlest to biggest. Our littlest find was 2 times 3, which is second, and also 11. If we had gone 3, you'd have had 66. 66 would have still gotten you the 11 eventually, more 2s, more 3s. If we had gone 6, 6 would have gotten you 33. That 33 would have gotten you 3s and 11s. The 6 would have gotten you 2s and 3s. I've done this too long, so I know 11 goes into that. I'd have gone 11 and 18, and I'd have split down to 18, and then I'd have gotten 2s and 3s out of it. But we're all going to get to the same place. 4675. 5 ends in 5. So take a sec and like long divide 5. And it's
935.
it is 935. That's the truth. Who can go into 935? 5 again, because it still ends in 5. So 5 into 935.
187?
is 187. And we can go into 187. Well, check your rules. So here's the thing to speed you up. The only thing we're hunting for is what types?
Prime.
Primes. So don't worry about trying to think of any numbers in the universe that go into 187. Only think about your primes. So we have a rule for 2. Does 2 work?
No.
No. Do we have a rule? We have a rule for 3. Add up the digits,
No. Wait,
because they add up to
60.
16. 3 into that?
doesn't
No. We have a rule for 5.
No.
No.
No. We don't have a rule for 7, so you would just have to try it.
No.
And it's a no. It's off by not much though. It misses by 2, because 2 goes 14, we'd have 47. We can go into 49, not 47, so 7 fails. Try 11.
No.
You didn't
Wait,
try
yeah.
it. Yeah, 11 will. So 11 in the 187 is a 1 to get you an 11. 77, it goes 17 times. So the answer to this is 5 times 5 times 11 times 17. Here's a frustrating part, unless you absorb the next detail I'm about to tell you, is sometimes you won't find any numbers that work. And there would be a lot of numbers to try unless you absorb my detail in about 30 seconds of how you can know that it's safe to stop. Because I don't think you'd want to sit here and spend the rest of the afternoon dividing in. If 11 failed, I would have had to try 13. If 13 failed, if you don't absorb my detail in a minute, you'd sit here and have to divide all of these numbers. And 41 and 43, and like there are more primes. You don't want to divide every prime that exists up as high as 187. Okay, that's crazy. But if I took 13 into it, let's say 11 failed. But say 11 failed. I would have had to try 13. 13 would be into 187. 1 so far is 13. Drop the 5. 7. 13 into this goes 14 times. This would give me the ceiling of how high I can go. Okay, so when, let's say when 7 failed, when 7 failed, 2, 14, 47, that's 6. When 7 failed, it meant 2 things to me. 7 is not going in this list, but the highest I'm going to have to divide is 26. None of these numbers will matter to me. 26 is my ceiling. I might still have to divide all of these, but I might not. If I tried 11, it hit, so that's not good to judge by. But if I tried 13 and it failed, it tells me the highest I have to go is 14. So if I tried 13, and the highest I have to go is 14, and 14 is not on the list, I would have checked out on 13 and just said, that's a prime. I'm going to rewind that little trick again. It helps you stop. So let me go to 107. So if I'm trying 107, I would first just think through from littlest to biggest. Does 2 work? No.
No.
Does 3 work?
No.
No.
No. Does 5 work?
No.
No. There is no trick for 7, so I have to do this. 1, it gets me 7, 3, 7, 5. So I just learned 2 things. I just learned that 7 did not work, but I'm going to get to quit as soon as I get to 15. 15 is the farthest I'm going to have to go checking for 107. So if 7 failed, who's my next check? 11. If I check 11 with 107, that goes in 9 times, which gets me 99, which gets me a remainder, which means 11 doesn't work, and the highest I needed to check was 9, and I'm already
At 9.
beyond that, so
You're done.
get out of it and be done. 107 is the answer. 107 is prime, and we can bail. But if you didn't absorb that trick and sat there and divided every prime up to 107, that's a frustrating, like, 10 minutes of your life, because nothing's going to ever divide in. You need to, like, it's good to understand that. The number you're trying, if it doesn't work, it tells you the, like, ceiling of where you get to stop. But only if you start at 2 and work your way up. Like, if you just randomly, like, oh, I'll divide in 19, oh, I'll divide 5, oh, I'll divide 37. No, that's a dumb way to do this. Start with 2, try 3, try 5, try 7, work your way up the list, and if you run out, sometimes it's time to just quit. Why didn't I put 107 times 1?
Because 1 isn't a prime.
1 is not a prime, and I only want primes. Something there? Let's take on this last one, and then we'll call it a day. When you were in 7th grade, I usually had you do this for bonus, and people usually try to do this in a way that I don't have board space for, by going, 2 goes in, like 72,000 times. 2 goes into that, like 36,000 times. 2 goes into that, and your tree ended up being like so big, because 2 is going to keep going in and in and in and in and in. That's not wrong. But can anybody think of a medium-sized way that you can split 144,000?
Can you do 1,000?
Yeah, do 144 times 1,000. And that's going to save us a lot of bother than peeling off 2's all day. If 144 is a memory from your times tables, that's good news. I didn't pick 144 by accident.
12 and 12.
That's 12 times 12. And now I'm going to barely squeeze this in, because 12 is 6 and 2, 12 is 6 and 2, and 6's are
2 and 3.
3 and 2, 3 and 2. How about thousands?
10 and 100.
I'd probably go 10. You could go 50 times 20,
It
but
would be 100.
probably 10 times 100 is more comfortable, with 100 being 10 times 10, and every 10 being
Maybe 2 and 5.
2 and 5. That's about the only way to squeeze that all in there. So what's the littlest number we had a lot of?
2.
2's, and it got a little messy, but 1, 2, 3, 4, 5, 6 2's you would have found. So if you could have kept peeling off 2's, that would have been a while. Who else did we find?
3.
3's, we found 2 of them, so there those are. Who else did we find?
5.
5's, we found
3.
3 of those, because we had 3 10's eventually, so there'd be 3 5's. What would be a way you could check any of these answers?
By multiplying them
You
all.
could multiply them all out. Something like that, you might not be feeling that. I'd say for something that big, go ahead, grab, I generally don't encourage calculator use, but for that one, any like sane person would use a calculator to multiply that up. So if you get real big and you want to use a calculator to check your homework, feel free. I would not, even myself, be doing 17 times 11 times 5 times 5. I just wouldn't be feeling that. But something like this, can you do 2 times 2 times 3? I would think so, and I would think that would actually help you a little bit in your mental math career to like do a little bit of math every once in a while. If you get too reliant on those machines, you probably have seen that in your own life. It's just like, it like leaks away. If you do it once in a while, it sort of like soaks back in, hopefully. That's what we are today, prime composite, but mainly prime factorizations. We're working 272 is our page. Generally speaking too, I think people are upbeat on the factor trees. Like, I don't know if you feel that, but more people than not usually see those factor trees and think like, oh, I like these, or at least I tolerate this. It's like not pain and agony, hopefully. But we're working 272. 1 to 32 is the name of the game. The first 28 are like what I did on the board, all these trees. They do play a little bit at the very end of the homework, the game I came in with. They'll say, who's the next prime? So they'll give you a number and say, what prime is next in the list? And they're working like 50s, 70s, 100s, a little bit farther than where I took you in the prime list. But they'll drop you a number on those last 4 and say, what prime is the next prime if we go? Just use those rules, the 2, 3, 5 rules. And everybody wishes there was a 7 rule, and there's not. There's no way with 7 other than just divide the thing in and see if it works. Anything, 272 questions about working the 1 to 32s? All right, thank you.